Biot Savart law. This law is used to find out the magnetic field intensity, that is magnetic field intensity, which is a vector at any point when a current is flowing in a conductor. Current is flowing in the conductor. So this is the total magnetic field intensity. Now this is a conductor, XY is a conductor, it is very long conductor carrying a current of I. Let us take a very infinitesimally very small length. This is dl. Infinitesimally, dl is the infinitesimal elementary length of the conductor. In this entire conductor, we take a infinitesimal element length of a conductor, very small. Infinite means very, very small length. And ideal, what is ideal? Ideal is the current element. Ideal is the current element. That is current flowing in that small, current flowing in the small element, that is I into dl vector. So why it is called a vector? This is called current element. Current through the elementary length is called current element. So this is a vector quantity. If it is a vector quantity, what is its direction? The direction of the current element is along the direction of flow of current. It means it is from here to here. This is the direction of the current element. dl is a vector quantity whose direction is same as the direction of current, where I is the current in the elemental length as well as current flowing in the conductor of length xy. And now suppose we want to find out at this point what is the magnetic field, because since current is flowing in a conductor, it will produce magnetic field around it. So at this point P, we are interested to find out what is the magnetic field at this point P. Due to this current element, we are just talking about this current element because current is flowing through this element, current is flowing and it is length is dl. So since current is flowing, what this length is producing magnetic field at this point, that we are going to find out using Biot Savart law. So now let us see from this place, this is the position vector. The position of this point with respect to the r is the, what is r? R is the position vector of point P with respect to this dl vector. And suppose if it is making an angle theta with respect to the conductor, this point P, the line joining the point P and with the conductor making an angle theta, that is this direction is dl vector, this is r vector. So theta is the angle between dl vector and r vector. So now we now it will, at this point it will produce magnetic field, this one, at this point also it will produce, at this point also it will produce. First let us find out at this point what magnetic field intensity this small elemental length is producing at that point, that we are interested to see. Now you see by Biot Savart, what he suggests that magnetic field produced by the small current element, not by the entire length, by the small elemental length, that is infinitesimal elementary length is directly proportional to current flowing through the conductor, and dB is directly proportional to the length dl. Small amount of magnetism produced at this point. See, it is producing a magnetic field dB due to this element, not the entire conductor. That's why it's a small amount of magnetic field intensity. It is also produced proportional to the sine of the angle between them, sine of this angle, and it is also proportional to 1 by the distance square. This distance in magnitude is distance square. If we combine all these things, the small amount of magnetic field produced due to this small length dl, this dl producing at this point is proportional to I dl sin theta divided by r square. So this can be removed. The constant proportionality can be removed with a constant proportionality into I dl sin theta divided by r square. So this constant proportionality can be replaced with some experimental value. See, this is dB. What this dB stands for? dB is the magnetic field. Repeatedly I am saying dB is the magnetic field intensity produced due to this current element, not by this and not by this entire this one. See, you have to remember Biot Savart law. Everybody says this is produced by this thing, this is produced. No. Where K, this can be replaced. dB is equal to mu naught by 4 pi, where K is replaced by mu naught by 4 pi into I dl sin theta divided by r square. This is the formula, and since it is a magnetic field, it will definitely have the direction. The direction can be found using right hand palm rule or corkscrew rule. We will use this law. This is easier one. So we will see how this is one. Since we have written the magnetic field, how to remember this law? How to remember this formula? The magnetic field produced by the current element is equal to mu naught by 4 pi into I dl sin theta divided by r square. This is what we have written. So we can simply use this word. Sin theta is ideal. That is, we can write sin theta is ideal. Remember this, you will get this formula. Add mu naught by 4 pi. See, in electrostatics we use 1 by 4 pi epsilon naught. Here this epsilon naught, it will go on the top and it will be converted into mu naught. What is mu naught? Where mu naught is the permeability of free space. Mu naught, there it is called permittivity. In electrostatic Coulomb's law, it is permittivity of free space. Here it is permeability. In magnetism, permeability of free space. Permeability of free space. So we are replacing it by this K is replaced. What is this K? The K is replaced by, here in electrostatics, 1 by 4 pi epsilon naught. In magnetism, it is replaced by this 4 pi is the top, it goes on the top, that becomes mu naught, which is called permeability of free space. Now with this now, dB is equal to mu naught by 4 pi, dB is equal to mu naught by 4 pi into I dl sin theta by r square, multiply and divide both the side by r. So this multiply and divide both the side, this can be written as dB is equal to mu naught by 4 pi divided by r cube into I into r, we can take it inside. I into dl into r into sin theta, because this we have taken it inside. I into dl into r into sin theta. So what is this? This is this we can easily recognize this one. How we can recognize? See, A cross B is equal to magnitude of vector A into magnitude of vector B into sine of theta into unit vector along AB. See, this is a vector. In scalar form, we remove this. Okay, so this is the scalar form, this is the scalar form. If you are removing this, that will the vector will be like this. So it means first vector I, second vector is dl. Sorry, I is a scalar quantity, dl is a vector, dl is in this side, and r in this direction. So both are vector, both are magnitude with sine theta. So this can be expressed. This can be expressed in vector form like this. How we can write? See, dB is equal to mu naught by 4 pi as it is, keep it, into I into dl into r into sine theta divided by r cube. See, one r is added, r cube. Don't get puzzled where, how here is r square, here is r cube, how it has come. Don't get puzzled. So now, this can be converted into, this is seems like some, that is a cross b is equal to ab sin theta in n vector. So in vector form, we can write db vector is equal to mu naught by 4 pi into, this is 1 to, this is I is out because it is a scalar quantity, into dl vector cross producted with the r vector. This can be written like this, r cube, because this portion a vector, b vector, and the sine of the angle between them. So dl cross r vector divided by 4 pi into I divided by r cube. This is in the vector form. If it is a vector form, how you are going to find out its direction? See, now this is the r vector in this direction. So what is dl is a vector into r cross vector. This is a vector cross product. Rest all, this is a magnitude. Rest all is magnitude. It means the direction of magnetic field is along the cross product of this vector, because cross product of two vectors is another vector which will also have its direction. So we use right and palm rule. This is right and palm rule. See, we have to go from dl to r. This is the dl direction. This is dl direction. We go, this is the dl direction. See, this is the direction of dl vector, and r is in this direction. This is the point P. R is, so from dl, first you have to go from dl to r, and this indicates the direction of the magnetic field. Dl, you go like this. That thumb is, extended thumb is inside. It means the magnetic field at this point is into it. The magnetic field at this point is into the plane of the paper. It means we can simply write what is this magnetic field vector here is like this, into the plane. Same way we can also find out at this point. At this point, if you want to find out, this is r vector and this is say point q. What is the vector here, whether into or outward? Let us see, we will go from r vector, see dl vector to r. dl vector is here, this is the r vector is here, r vector is here. So we keep the right hand here, r, this one, this thumb is pointing outward. Outward means the magnetic field at this point is outward. So this way we can find out using the right hand palm rule. Right hand, as long as the cross product of two vectors are concerned, the right hand palm rule will be much easier than corkscrew rule. That's why I have not discussed about corkscrew rule. So now we can summarize all the things. How we can summarize the Biot Savart law? One thing we have to remember here is that this is the magnetic field that is magnetic field. This dB vector is magnetic field produced by whom? By the entire length of the conductor? No, it is produced only by the small current element, this portion current element. This is produced by small, infinitesimally small elemental length dl, and therefore dB vector, first we will write dB is equal to, we will write 1 by 4 pi epsilon naught 0, 4 pi epsilon, it will go on the top, sin theta is ideal divided by this one. In vector form, dB vector is equal to mu naught by 4 pi into I into what is this? We can write I into dl vector cross product with the r vector, where r vector is the position vector of this point P with respect to this dl vector, divided by r cube. And if the conductor, the point is P is here, this is r vector and this is theta, and this is our dl vector in this direction. So palm rule, dl, because dl to r, it means at this point it will be inside. Suppose we want to find out at this point P, due to this current element, same current element, it will become mix up. So I write it here. This is a dl vector in this direction. This is the r vector in this direction. So right hand palm rule, dl vector to r vector outward. So here the dB vector is outward. This is here, dB vector is inward. This we have to remember as far as the Biot Savart law is concerned. Now we have talked in something about the magnetic permeability of free space in magnetic field. In electrostatics we talk about permittivity of free space. In magnetism we will be speaking about the permeability. Here permittivity in electrostatics, it's permittivity. See, dB vector is equal to mu naught by 4 pi into I into dl vector cross r vector divided by r cube. Mu naught is equal to permeability of free space. Permeability of, what is its unit? See, look here. This here we can get the unit here itself. This is magnetic field is in Tesla. This is Tesla. Mu naught. So we want to find out unit of mu naught. 4 pi has no unit. 4 pi has got no unit, and current is in ampere. Divided length is in meter, into this also into meter, and divided by meter cube. So this has got no unit, we need not to write it. So we can write this meter, this get cancelled. So mu naught is equal to T m by A. This is the T m by A. This is the unit of Tesla. T stands for Tesla, m stands for meter, A stands for ampere. This is the unit. And mu naught, what is the value of mu naught? Mu naught is equal to 4 pi into 10 to the power minus 7. Since 4 pi does not have any unit, mu naught is equal to Tm by A, or mu naught by 4 pi is equal to 10 to the power minus 7. Here also this does not have any unit, so here also same thing is applicable. So Tm divided by A. So the unit of permeability of free space is this one, and the value of this is the numerical value. Numerical value should be numerical value we should be able to recognize. See, in Coulomb's law of force is equal to 1 by 4 pi epsilon naught into something, that is Q1 Q2 divided by distance square. So here magnetic force, here magnetic field by a see we can find out how we will find out the entire magnetic. See, this is the for the small portion. So if you want to find out for the entire portion, mu naught by 4 pi into I into dl cross r divided by r cube. If you want to find out total magnetic field due to entire current, then integrate it. It means you have to integrate here also. That is how we are going to find out. dB, what is here force? Here magnetic field 1 by 4 pi. The 4 pi we will keep it. We will take this one upward. This will be mu naught by 4 pi into I into dl cross r. This is the difference between magnetic and electric field. So okay, and mu naught by 4 pi, its value is equal to 10 to the power minus 7 Tm by A, and 1 by 4, and here also 10 to the power minus 5, and we can say 1 by 4 pi epsilon naught can be written as 10. We have already seen 9 into 10 to the power 9 into 10 to the power 9 into some value, that is epsilon naught means meter square, it is values. So we will find the value because there is no space to return here. So with this way we should be able to differentiate. Mu naught by 4 pi value is equal to 10 to the power minus 7 Tesla meter divided by ampere, and mu naught is equal to 4 pi. If you want to find out only mu naught, take this 4 pi here. Mu naught is equal to 4 pi into 10 to the power minus 7 Tesla meter by ampere. Now let us find out the magnetic field produced at with vector. It's a vector at any point on the conductor itself. Conductor itself. That is very simple. See, this is the conductor, this is the dl vector, and current is flowing. So dl vector will be in this direction at any point. P is at any point on the conductor. This is the conductor on the point. What is the angle? See, mu naught is equal to, what is dB? dB is equal to I into mu. So dB is equal to mu naught by 4 pi into I dl into sine of, what is theta? See, dl vector is in this direction. In this direction, we know dl vector is in this direction. It is along the direction of current, and r vector in this point. So r vector will be also in this direction. So it means we can say this is dl vector in this direction, r vector, because the point P is here. So we will take r vector like this. This is r vector in this direction, and theta, angle between dl and r, theta is equal to 0 degree, and sine of 0 degree, because theta is equal, here theta is equal to 0 degree. It means dB is equal to sine of 0 is equal to 0. This 0 multiplied anything is equal to 0. It means we can conclude that the magnetic field at any point on the conductor, at any point P on the conductor itself, this is produced is equal to 0, and direction as it is, once the magnetic field is 0, we need not to worry about the direction because it is a 0 vector. Now let us take an example. Suppose it is given to us that if the current is equal to 8 ampere and elemental length is equal to 1 centimeter and the distance r is equal to 200 centimeter and theta is equal to 45 degree. So how we will calculate? See the dB. This is dB. Okay. So dB is equal to of course the current direction is, let us assume the current is in this direction and this is the point, and this angle theta, this is theta. Let us assume dB is equal to I is equal to dB is equal to mu naught by 4 pi into I into dl into sin theta divided by r square. Let us later find out, as it is the direction is, we can find out after finding out its magnitude. What is the mu naught by 4 pi? Mu naught by 4 pi is equal to, as it is, 10 to the power minus 7. That is, we can write it also, mu naught is equal to 4 pi into 10 to the power minus 7, and 4 pi 10 to the power minus 7, divided by 4 pi, because its value is this one, into I. What is the value of I? Is equal to 8 ampere. And dl, what is dl is given is 1 centimeter, that is 10 to the power minus 2 meter. We have to write it in meter, everything we have to keep it. And sin theta is equal to sin 45 degree divided by r square. What is r? R is equal to 200 centimeters, that is 2 meter, 2 square. So this we can see 10 to the power minus 7 into 8 divided by 4 into 10 to the power minus 2 into 1 by root 2. This we can write. So this is answer is equal to, this is 10 to the power minus 7, 10 to the power minus 2 is equal to 10 to the power minus 10. Since it is a magnetic field, it will come in Tesla. 8 by 4 is equal to 2. So 2 can be written as 2 root 2. 2 root 2 divided by root 2 is equal to root 2. So is equal to root 2 is equal to 1.414. So and 1.414 Tesla is the magnetic field produced by the small elemental length at this point P. If the point P is here, the magnetic field direction will be inside. If the point P is here, this we can take, theta will come like this. Now in that case the magnetic field will be like this, coming outward. This is inward. So this is the magnetic field produced by this current element. See, again and again saying this law gives the magnetic field produced by a current element, not by the entire length of the conductor. To find out the entire length, you have to integrate this equation either in vector form or in a scalar form. But of course, finally we will give the directions.